Welcome to episode 283 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
All right, Rob, how are you doing?
Doing okay. You mentioned you were doing some more streaming this afternoon?
Yeah, I'm going to be starting a stream in almost exactly 2 hours from now, but it'll be far too late by the time our listeners actually get this episode. I just haven't done any streaming in like over 6 months or something, so I thought, yeah, what the heck, I'll play with it again.
What are you planning on doing?
I can't aim my camera at it or anything at the moment, but I have a Raspberry Pi here set up with 4 I2C devices connected to it.
Oh.
And it's just been so long since I've done any kind of embedded development. I thought that I would try to see if I can get these things talking to me with C++.
Very cool. Very cool. Okay, well, at the top of every episode, I'd like to read a piece of feedback. This week, we got some comments on Reddit. This one is from Reddit user Kalmok on last week's episode, and he writes, with respect to networking, can't we get at least some basic concepts and vocabulary types into the standard, like buffers, maybe callback signatures, types for IPv4, v6 addresses, domain names, URLs, and maybe synchronous sockets? And yeah, I think that all sounds great. And I'll just say, Cornton made it clear last week that was just his opinion, but it seems like the rest of the standards committee is still trying to get the full networking library in, so we're not really sure how that will play out, but we definitely don't think that networking is like dead on arrival or anything right now.
No, and I think that's kind of, I just wanted to say that the linear algebra proposals that have come out of the graphics proposal look like they'll hopefully at least also just get some vocabulary types into the standard at the very least.
Right, and I do think that was a good way to kind of continue getting something out of the graphics proposal, getting those vocab types. Yeah. So if networking does go down, and I'm not really sure what my opinion is on that now after talking to Cornton last week. But yeah, if it does go down, hopefully we would get something out of it, like vocabulary types. I do agree with this comment, but we might still get the whole thing. We'll see.
Yeah, we'll see.
Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Alessandro Pignotti. Alessandro is CTO and founder of Leaning Technologies, born in Rome, moved to Pisa for his computer engineering studies, spent several months in the US, and lives now in Amsterdam. He started the LightSpark project, a C++ open source implementation of the Flash player, back when we had lots of free time. Alessandro is fond of movies and sci-fi literature. Alessandro, welcome to the show.
Thanks a lot, Rob, and thanks a lot, Jason, for having me here.
I am so curious about your free implementation of the Flash player, although I think we might get into that a little bit later in the interview with some questions that I want to ask you later. But
Sure.
I am curious what sci-fi literature you're reading currently.
So pretty much a couple of years ago, I joined a book club with some friends here in Amsterdam, and the book club is about futuristic literature, and we read both fiction and non-fiction stuff. But I sort of redeveloped my taste for sci-fi. But to this day, I think that the most fascinating one I read was the Forever War. Have you read this one?
Forever War, no.
I don't remember the author, but it describes the dynamic of war between humans and an alien civilization in a world where there is no faster than light travel. So it takes a lot of time to actually move between space, and you will never know when you meet the opposite faction what technology they will have, because lots of time has passed.
Okay.
I found it really fascinating.
Yeah, that sounds like, obviously I haven't read the novel, but like, why would you bother if it takes generations to get to the other planet or whatever? But
that's a good question, I guess.
I will, but war rarely has logical roots, right? So I'm just going to pull that up to look at that later.
Yeah.
Cool.
Okay. Well, Alessandro, we got a couple news articles to discuss, and then we'll start talking to you more about Cheerp, okay?
That's fine, sure.
Okay, so this first one we have is Mold, which is a modern linker. And this is a GitHub repository with a very nice-looking README. And I thought I was interested when I first started reading through this that the main goal of this project was just to be faster than Cat. like the command used to concatenate
as a
objects.
linker, faster than cat. Yeah.
Right. I didn't think that would be like the main way to improve on performance, but yeah.
Yeah, but I sort of see the idea there because in the end, most of the time in a linker is actually spent, copying the sections in and out from the input to the output files, which is sort of what cat does. Then you also need to do relocation, all this sort of logic. But I could see what could be the reasoning behind, let's compare to cat.
And also, I mean, yeah, if it can get to the point where it is like actually faster to link than it is to just concatenate files, that would be really impressive.
That, Jason, it sounds a little bit, I guess it depends, it's a matter of semantics there, because that is achieved, if I understood correctly, by keeping around a pre-linking step, sort of a daemon that would just keep an up-to-date idea of the files in internal data structures so that you can link them faster. So I would argue that that shouldn't count. It's not like it really matters. In the end, the tools are intended to do, if they do their job fast, it's great. But I'm skeptical that that comparison is fair.
Okay.
Okay, and then the next thing we have is a post on the C++ subreddit, and this is for C++ jobs that are being posted in 2021 Q1. Were there any specific jobs you wanted to highlight, Jason, or just kind of let listeners know that this is still being posted every quarter, and it's definitely a good resource for if you're looking for work?
Yeah, I was just thinking, I don't know if we ever mentioned it on the show. Maybe we have, but once a quarter on the C++ Reddit, if you're actively looking for a job or are looking to hire people, they have a sticky thread there.
Yeah, and they all have very well-written job descriptions. They're all definitely for C++ jobs. And I think one of the requirements to make a posting here is that you need to have like a direct link to your company and not just like to a recruiter. Otherwise, this probably would get flooded with recruiters posting things.
I've been getting some particular recruiter lately that has been contacting me. Like the local like main bakery in town needs a logistics person. And I'm like, why are you sending me this? Like, yeah.
Well, they're doing their jobs.
Yeah.
I guess they're doing some
job.
Some job.
Okay. And then
something I can add here is that LeaningTech itself is looking for an intern right now. Okay. So we just started looking for it. We have not yet added to the listing. We have done it. We actually used the Reddit thread for our previous hire. We didn't find it through the thread, but we did post it there. And I think we will also post the intern position as soon as we get the time. We are super busy, so sometimes we don't work as efficient as we would like on the HR side.
Is the company based in Amsterdam?
Yes. So actually we are partially in Amsterdam and partially in Leeds, UK, but the technical team is fully here in Amsterdam.
Oh, okay.
And so are you hiring people who are remote, or do you want someone ultimately who can move to Amsterdam?
I think we will be strongly preferring a person that could move eventually here. Even better, possibly a person already here on site. Maybe we're looking for a junior position, an intern, so probably somebody from the university, from the various universities of the country will be best suited. But we will not exclude anybody from this.
Okay. And I am reluctant to ask, but I'm still going to anyhow. Does the fact that half of your company in the UK, is that going to be a problem anytime soon?
So, the fair answer to this is that we have no clue yet. This is how the situation is. This situation is incredibly confusing. Honestly, I think we are on the safe side since we have structured we have companies on both sides of the channel. So if everything goes very bad, we have a European company that we can use to keep the business going. It's going to be okay.
I just recently saw an article about a bunch of UK residents with .eu domain names that had all of their EU domains suspended pending the ability for them to transfer the ownership to someone who is actually a resident of the EU.
Yeah, to me what is crazy is that there is such an incredible amount of small details connected to Brexit in various ways. It's very difficult to, see all the ramifications down the line. Every single thing that needs to be changed.
Yeah.
Okay, the next thing we have here is a post on the CPV subreddit again, and this one is a slightly better assert using C++ 20's stood is constant evaluated, and this has a nice Godbolt link. You want to tell us more about this one, Jason?
Well, yeah, I mean, if you try to use assert from a constexpr function, then you'll see very quickly that you can't, because assert is not a constexpr function. I mean, it's a macro, but what it does is not constexpr. So I've actually done tricks like this myself already recently to do if is constant evaluated, then do something else, otherwise call assert. And so it's or do a debug statement or something like that. So I just thought this was an interesting read. And then a bunch of people were posting it on the subreddit for possibilities for how this could be enhanced with other language features that we don't have, but, options for the future.
Yeah.
Yeah, this was interesting to read for me since I tend to write very defensive code. I tend to litter my code with assertions all the time, and I never figured out that this could have been, that using assert in a constant text context could have been a problem. So I learned something there. Thanks for sharing this.
Cool. Okay, and then the last thing we have is a post on the Old New Thing blog, Raymond Shen, and this is, how can I write a C++ class that iterates over its base classes? And obviously, this is something that we hope will be solved someday with C++ reflection. It's, but it is possible, and Raymond Chen showed an example of how you could do this with C++ today.
But did you feel, guys, that there is an actual use case for this? So I appreciated the trick. I'm not sure I see the use case.
Yeah, I kind of felt the same way. I don't know. What do you think, Jason?
I have needed to use something kind of like this. Well, maybe not exactly like this, but in a couple of cases where use similar techniques when you're doing the merging multiple lambdas into a visitor for calling on variant. And I've used related techniques when implementing a version of tuple that did not require recursive template instantiations. So it is possible to implement tuple without recursive templates. It makes it much faster to compile, and you kind of use something-ish like this because you have to use multiple inheritance, and then you have to do things to be able to visit all of the members of your base classes.
Cool.
Cool. Okay, so Alessandro, I think we've talked about Cheerp once or twice on the show in the past, as a news update. But let's hear more about what Cheerp is from you, right?
Yeah, sure. So what Cheerp is a compiler which is designed to make C++ a first-class language in the web. So to solve this problem, of course, you need an efficient and high-quality WebAssembly code generation backend, but that's just one part of the problem. The thing is that WebAssembly by itself cannot truly do that much because it is designed as a very self-contained sandbox. And to give you an example, it is not even possible to truly write an hello world in pure WebAssembly. Pure WebAssembly by itself cannot even write something to the console. And any input-output is actually achieved using what are called WebAssembly imports. So imports are a set of JavaScript function, or more in general, function coming from the environment that you give to the WebAssembly module, and then the WebAssembly module will be able to use them. Okay, so pretty much what we did to solve the whole problem of making C++ a first-class language for the web is to implement a brand new, fully working code generation that also works directly in JS. So the great thing about Cheerp is that you can write a single C++ code base, and then you can compile it to a combination of JavaScript and WebAssembly. And there are a bunch of rules that you need to follow. There are some complexity there, but the idea is that with Cheerp we have pretty much fused this complexity into the type system. So the compiler is able to guide you in this somewhat convoluted process. And the end result of this is that you can pretty much directly use browser APIs or JavaScript APIs or any object coming from the DOM directly in C++. And if for any reason you make a mistake and you're trying to do this from WebAssembly, which is not allowed, the compiler will tell you, you will know at compile time, and you will be able to rework your code to avoid this problem in the first place.
So what does this actually look like when we're calling, it sounds like you said we can call JavaScript functions directly from our C++. Did I understand that correctly?
It's one of the things you can do. Yeah, sure.
Okay. And what does that look like? Do we have like strongly typed actual function wrappers or something that's available at compile time?
So the way we express this is that we have pretty much decided that there is a special namespace, which we call the Namespace Client. And inside of this namespace, all the classes and functions that the browser defines are available with strongly typed interfaces from C++. Oh, nice. So you can literally call, to make you the simplest example would be client namespace console.log. And you're going to call the console.log that the browser provides. The cool thing about this is that these are all declarations. There is no implementation from us. So this does not require re-implementing of the browser. You're just exposing to C++ what already exists in the browser. And it's also cool that this mechanism is extensible. So there's really nothing special about the browser's function. This is just a bunch of declarations which are available out from JavaScript. So you can also use any JavaScript library pretty much. Or you can, if the browser is extended with new APIs, you can write the headers yourself. You don't even need to wait for us to update the interfaces.
Awesome.
Yeah, very cool. Whenever we talk about WebAssembly, we usually wind up talking about emscripten, which is kind of what WebAssembly came from. How do you compare Cheerp to emscripten? How are they different?
So I think that a good perspective here is to see that the scope of the Cheerp project is just much larger. Okay. So pretty much emscripten at this point works together with the upstream implementation of WebAssembly in LLVM. Historically, the generation of WebAssembly was part of emscripten, and now it's merged into upstream LLVM. And at this point, emscripten works both as a front end, because it offers a bunch of script that makes it easier to port existing code, and also some libraries are already ported so that it's easier to use existing code. And then it also works as post-processing steps, since at least the last time we checked, the code generation of the upstream LLVM is actually not very efficient, and it is assumed that we'll run a tool which is called wasp-opt on top of the output of the of LLVM itself, and this is all abstracted away by emscripten, and will do all these various steps which are required to get an optimized output in the end. So in terms of pure WebAssembly output, at this point, Cheerp and emscripten are quite close. There are some things that I think we do better, some things that they do better. We always try to catch up. But something nice is that everything we do it without external tools. So Cheerp is completely self-contained, and the output is already high quality to begin with. But all this is only for the WebAssembly part. Then there is all the other things we were discussing before. So all the JavaScript code generation and the interoperability with JS, the JS export feature that we implement, which lets you write a C++ class and then use it from JavaScript. So, the other way around in terms of interoperability. All of these are features that have pretty much no comparison from emscripten.
So you just mentioned writing a C++ class, being able to use it from JavaScript. This kind of cross-language interoperability with scripting languages is something I've spent a lot of time with, but mostly from the Swig perspective, using Swig to generate the interface bindings and such. So how does that work? Can you give us some insight into how your tool actually takes the C++ and makes it visible in JavaScript? In JavaScript.
Yeah, sure. So the idea is that we tend to use lots of custom attributes to do what we do. So it's a very general tool that can be used for a lot of purpose. And so we have this special attribute that you can apply to a class, but also to freestanding functions, and this Cheerp JS export. And when you do that, the compiler will actually enable a bunch of additional checks. And these checks will make sure that what you write can be successfully exported to JavaScript. So the idea is that, of course, there are limitations to what we can do, but one of our policies is that if something is not supported or impossible, the compiler will tell you a compile time. So stuff will not explode at runtime without any warning. We try to make sure that if something compiles, it's also going to work. And the idea will be that if a class is tagged as just export, it will export our pretty much a JavaScript class. So we'll have a constructor which is defined with all the various methods added to the prototype. So it will be very natural to use it. And it's very elegant to me that this works. This is tightly integrated with the JavaScript code generation of Cheerp. Because one problem that you have is that it's about the lifetime. So in C++, you have a very well-defined lifetime of objects, but when you allocate them from JavaScript, this is not clear anymore. And it's unclear when will be the destructor be called. Well, the answer is never, because you have no visibility on the garbage collector. So the compiler also imposes some rules that, for example, the destructors have to be trivial and so on and so forth, so that it's going to be safe and valid to use that code from directly from JavaScript.
Okay, so no sharing shared pointers between JavaScript and C++ with Cheerp.
Well, actually, you could do that. It's important that you need to control the lifetime yourself. So if you need to have pretty much an explicit deallocate or free function that will free the shared pointer, but you do not expect the destructor to run, and the compiler will let you know that this is the case.
Okay. Now, all of these attributes that you just mentioned, do they get in the way? Like if I wanted to share the same code base between like pure C++ library and Cheerp JavaScript land, is my compiler going to complain at me because I have all these attributes that Cheerp wants?
So in one direction there's going to be no problem, right? So if you take existing code and try to compile it with Cheerp, there will be no attributes there, so stuff will work. Of course, you will not have it exported. That's the default behavior. But in the other way around, if I recall correctly, unsupported attributes are ignored by the compiler. So you will get a warning, but the thing will not fail at compile time. I guess that to this date, the right way of dealing with this sort of sharing will be to define a bunch of if-def macro.
Okay.
In the end, multi-platform support works like that. It is not great, but this is how it in practice works.
Sometimes it happens, yes.
Okay. I'm kind of curious. Have you had any success stories of taking existing, C++ like desktop or mobile applications and bringing them onto the web with Cheerp?
So yeah, actually a bunch.
Yeah.
So for a while, our company offered the service of porting mobile games to the web.
Okay.
Which is actually a pretty great use case because the games tend to, so everything that runs in the main thread of the browser needs to be asynchronous, needs to be event-driven, because if you have an infinite loop, the browser will stop responding, which is not great. So, but games follow this sort of pirating, right? They have a frame function which is called over and over again to update the state and show new things, and also mobile games are based on GLES2, which maps perfectly to WebGL. So we also offer a compatibility library there, so it was very, very easy to implement. And we did a bunch of this. It works very well. And all of this was before WebAssembly time. So we made all this porting with pure JavaScript. And it works fine because something that is nice is that so Cheerp is a true compiler, right? It's not just a transpiler that tries to convert C++ expressions to JavaScript expressions. Stuff is actually compiled, which means that the output is also efficient. Not only that, but there are a bunch of tricks that you can do to make it so that when the JavaScript code is actually executed by the browsers, it is fast. So if you follow a bunch of very subtle rules and which you can figure out by taking a look at the internals of the JavaScript engines, you can achieve a much higher performance of what you could do when you write code manually. Which is also a nice side effect of having something that can generate JavaScript for you.
So you said like games, they have this infinite loop main thing going on, and if you just directly translated that to JavaScript, it would cause the browser to hang. But you can do that. You can just recompile your game that has a main loop in it, and Cheerp takes care of that problem? somehow?
No, you will do it. So with Cheerp, we try not to make magic solutions, but we try to offer the programmers the tools they need to solve the problems. So we try to reason, well, at the programming language and compiler level, not truly at the framework level. We don't believe that's our job.
Okay. So what does that actually look like then? What does my game loop become if I want to compile it with Cheerp?
So the idea, to make you a practical example, is that so we have ported lots of Android games, okay? And these Android games are most usually written in C++, but then they are driven by a Java front end, right? Because Android actually uses Java apps. So what you will do will be to sort of remove the Java part and take whatever is the C++ function that they call on update and call it from request animation frame, which is an entry point from the browser, which is called at the refresh rate of the monitor to provide fluid animation and games pretty much. So it's just that you take all the core, you disconnect it from the Java part in the case of Android, and you reconnect it to the interfaces that the browser provides. But the good thing with Cheerp is that also this glue code, this connection part, is solely in C++. Because that's the whole idea of this project.
Cool. What does performance end up looking like when your Java/C++ game has been recompiled to JavaScript with Cheerp?
So when you compile to JavaScript, you usually get a performance hit, maybe 4x, 6x, 6x, something like that. But you also need to take into account that this was in the old world. This was before WebAssembly. So nowadays you will actually compile to WebAssembly and get something between either native speed or 2x, and only use JavaScript for the parts which are either need to interface with the browser or in the end are not so performance sensitive. The thing is that it's not so bad as one could think.
It sounds like if you're going this route, you would want to limit the amount of calls that you make back into the browser. I just feel like that would have to be one of the bigger bottlenecks.
I'm not sure. So it is historically true that the DOM is not very fast, but in my experience, that was never truly that much of a concern. Also, the amount of calls that go, when you write code with Cheerp, you tend to have a certain amount of code that goes from JavaScript to WebAssembly back to JavaScript and so on and so forth. But it doesn't seem to be a problem in practice. That's fine. So the cost is pretty much a call. So if the call is expensive, then it means that your inlining threshold is where you need to tweak. So you need to add the inline keyword to the function pretty much. But it's not so different compared to native, right? It's the same sort of reasoning.
Okay. I think we saw some things on the Cheerp website about Cheerp-specific optimizations compared to emscripten or normal WebAssembly. Do you want to tell us a little bit about those?
So yeah, so the thing is that to achieve high quality code gen, there is truly no silver bullet. Okay, there is no single optimization that solves the problem. You can go home and rest for the night. It's just a large collection of very small things that overall give you high quality code. And whenever we do something, we always take into account, as I was saying before, one level deeper. So we always look at how the actual engines in Chrome and Firefox in particular, how the engines generate native code from WebAssembly or JavaScript to decide how we generate the code in the first place. So we try to bridge this gap between this additional level of virtualization that is in the middle. But okay, taking this aside, there is also a few optimizations that are somewhat larger, and we gave names to them. Also, giving names to something is nice when you have to write a blog post and mention something that people can read and talk about. So yeah, one of the things which are, so more in general, we always work, so the optimization we do always happens at the level of the LLVM internal representation, okay? Which means that we have a lot more information compared that if we were trying to optimize just WebAssembly code after it has been lowered. So working at a higher level gives you more information, which is better for optimization purposes. So and one of the optimization which is possible by using this approach is what we call the globalizations of globals, which sounds a little bit weird, but the general idea is that WebAssembly has an independent address space for global variables, which is outside of the main memory you will normally use. And it is possible by analyzing the use of globals to figure out if they never have their pointer taken. And in that case, you can actually put them into the global space of WebAssembly, which makes for a slightly smaller code and also slightly faster in some cases. The same technique can actually also be used for constants. For example, large double constants, they fit much better into the space of WebAssembly globals compared to the actual regular memory space. Also, using the high-level LLVM IR, we can also do some advanced de-virtualization, which is an interesting problem because you can actually do... De-virtualization works in two ways. Because on one side, if you can prove that a certain indirect call always has the same target, you can change it to a direct call, and that's fine, that's great. But then you can also maybe prove that there is no possible target for an indirect call, which means that that code can never be taken, which means you can that code eliminate all of it. So there are a bunch of nice optimizations you can implement by reasoning over the possible call sites. Then there is also pre-executor, which is probably the most brand name optimization that we have. And pre-executor it's pretty cool. And it is designed pretty much to reduce code size and startup time by consuming and removing the global constructors that are used to initialize global data.
Oh, okay. Interesting. So you said, I have several things I want to discuss.
Apologies. I think I said too many information all at once. Apologies.
Perhaps. Let's see. I was the de-virtualization that you're talking about doing. That is a step more than what LLVM can do on its own.
Yeah. So the idea is that pretty much after we have done our regular dead code elimination and we have reduced, using normal techniques, the amount of code as much as possible, we then take an additional look and we use both rules of the rules of WebAssembly and the rules of C++ to limit the set of possible callees. So the idea is that in WebAssembly it is illegal to indirectly call a function with the wrong number of arguments or with different types in the arguments, okay? So this means that you can rule out any call to something which is not signature compatible, because otherwise it will anyway explode at runtime. Mm-hmm. So it's safe to remove it directly at compile time at that point. So the platform gives you some guarantees about what is legal, and you can propagate this information to remove some additional code.
Is that something that could theoretically be done in a whole program optimization setting with LLVM?
I would say certainly yes. So where there is no magic. If something can be done by us, it can also be done by LLVM upstream. It's just a matter of figuring out what is the best way what is the best place in the toolchain to do this. Of course, we always update, we rebase our work on top of upstream LLVM. So if eventually upstream LLVM catches up or CLang, that's great. We just can take advantage of whatever technique they've implemented as well.
Right. How hard is that, by the way, keeping your patch set so that it can be rebased on top of? Or are you modifying LLVM, or are you working at a level higher than that, just taking the IR and modifying it and then re-injecting it into the WebAssembly generator?
No, we are deeply integrated. So keeping up to date is sort of a challenge. Over time, we have developed a process that seemed to work pretty well and is not so time consuming. Still, LLVM tend to change quite often, tend to break APIs quite often, so that's not great. So some of our long-term plans is to try to decouple us when possible. So for example, we would really like that all the front-end checks that was describing before, so all this fact that the compiler can tell you at compile time what is valid and what not, we will try to move it outside as a CLang plugin, so that at least we will not have that part which is fully integrated in the code base, but we have not yet started working on this project. So, and eventually we really hope to contribute some of our ideas back, but currently we really never had the time to do it so far.
Rob, I'm just reminded of our interview with Patricia from a couple weeks ago. We're discussing her pain with trying to work with Chrome, which is a constantly moving target as well.
Yeah, also Chrome takes 10 minutes to compile on my, to link, 10 minutes to link, just to
To
link
link.
on my computer, and takes overnight to compile.
Yeah, that's what we're talking
Yes, and
about, building Chromium. Yeah.
apparently following her most recent tweets about that building Chromium, you do have to use Google's version of Clang to be
I
able
think
to
they
even
ship it.
compile it now.
I think they ship it together. So I think they
Yes,
ship
that's
the
yeah.
full chain.
That's part of the annoyance there. But anyhow, that's just an aside. Now, I'm curious about your pre-executor as well. You said it's mainly used to eliminate startup code. Did I hear that right?
Yeah, that's so. Let me make you an example there. So let's say that in C++ you allocate a global string. So okay, an std string in a global space, and you
Yes.
initialize it with a constantly string literal. So let's say that a sufficiently smart compiler, especially now maybe with constexpr, it will be able to figure out that this is just constant initialize and just create the right layout in memory for this class.
Right.
The thing is that this actually happens in practice. It's not so sure, and of course you might have a more complicated data structure where it's not viable. So the idea is that when the compiler cannot truly convert this initialization to pure memory layout, it will create what's called a global constructor. So it will create a small function that inside contains a call to the constructor for that specific global object. And if you start doing this a bunch of times, you will end up with maybe possibly hundreds of these constructor, which are all executed before main is even started. Okay.
Mm-hmm.
So normally in native you maybe don't even notice, so it's not so important, I guess. But when targeting the web platform, both the code size and startup time is a very sensitive metric. So the idea of pre-executor is that we actually run all this code inside the LVM interpreter while compiling the code. So we take the code that we have just generated from LVM and we execute it in the interpreter. And then we observe what the interpreter does. In particular, we observe the memory allocation and the memory writes, which are done. And at the end of this project, we are able to, well, if everything goes according to plan, of course, this might fail and the compiler will bail out and keep the constructor as it is. But if everything goes according to plan, we are able to extract an actual, just the memory layout of what you want in the end, okay? So you don't have the constructor anymore. You just have a global and its corresponding constant that describes the initialization of it at the LVM level. The next step is that at this point, the compiler can further optimize, because if this string is not used anywhere, this is just gonna be dropped, and right. In this case. But maybe it's only used used read-only, so maybe it can be constant propagated into the user code. So there are a bunch of things that can be done after pre-executor, which are pretty cool. And so in practice, for one of the games we ported years ago, using pre-executor made the size of the generic code, made half for the size pretty much. It went down by half. That was a little bit of a pathological cases. They had thousands of strings allocated in the global space, but this stuff can happen if you don't think too much about it.
Okay. So can it be used, or do you use it for other possibilities, like pre-executing pure functions like sine or cosine or something like that?
So I would guess that in the case of sine or cosine, probably they will just be constant propagated by the compiler itself. I'm not sure, but I think I've seen code for that, at least in some cases.
Right, sure.
So possibly an interesting expansion would be that so far we deal with everything that happens before main, right? But there is also a bunch of code, maybe usually in the main of a function, which is still initialization. You're still allocating a bunch of either singletons or persistent data structures or whatever. It could be interesting to expand pre-executor to also try and execute as much as possible from the main function itself. So right. Pre-executor, of course, stops as soon as something becomes unpredictable. If you try to query the time of the day or anything random or access a file or anything right. which cannot be known at compile time, it will stop. But all the initialization which does not require any of this input data, it could in theory be pre-executed as well. This is something that we've been thinking for a while. We never got to try and work on this problem, though. It is an interesting possibility.
Yeah, it's like, I imagine like constant folding on steroids, basically, to just do everything that can be done, yeah. I guess that's more like how D works, I believe. D is guaranteed to do that, execute anything at compile time that could be executed at compile time. But
okay. Can you tell us a little bit more about, if listeners want to get started with Cheerp? We did see on the website that you have a commercial and GPL license. What do those options look like?
So the idea is that, if you just want to test and try something at home, you can just use the GPL version because you're not releasing anything, so there is no effect whatsoever if you just want to try it out. The idea is that if you're not comfortable with publishing your code as GPL after you're done with it and you want to publish it, then you need to acquire a commercial license. Of course, we also offer highly discounted licenses for individuals and indie developers. So I think that part is fair and it works. We really hope that in the future we will be able to relax the licensing requirement. We would like to just release everything under a more permissive license, but so far we cannot yet commit to that. So we hope that as the company grows, we will be more comfortable in betting that more adoption will just convert more without worrying too much about it.
Okay.
I noticed.
Oh, go
ahead, Rob.
I was just going to say, are there any features that you get if you do pay for the commercial license that aren't present in the GPL?
So there are a couple of add-ons that we offer, which we've seen that tend to be more useful for commercial users. In particular, there is some additional support for emulating the file system and a partial compatibility with emscripten. So there is a bunch of custom headers and libraries from Script that you can use mostly to interface with JavaScript. So the part that it's integrated in Cheerp needs special handling in the case of emscripten, and we provide some compatibility with that to provide a migration path. But mostly the main thing you get is that you don't have to release the code.
Okay. And we've mostly been talking about the Cheerp like WebAssembly compiler, but there's other Cheerp products as well. Do you want to tell us a little bit about some of them?
So they let's say that part of a familiar product, but they're not part of Cheerp. So they have similar name, but CheerpJ and CheerpX, they are not truly part of Cheerp, different products. But they are still very connected though. So the thing is that our technical team is made of 4 people, including myself. When the intern comes, we will be 5. So we're a very small team. And nevertheless, we are making 3 products which we believe to be sort of state-of-the-art in what they do. So the way we can do this is because there is a lot of synergy between these products. So, for example, CheerpX, which is our virtualization technology that makes it possible to execute x86 binaries safely in the browser, is written in C++ and compiled using Cheerp. For CheerpJ, we generate JavaScript code from Java in this case, and we use the same JavaScript backend that we use for Cheerp. So we recycle the JavaScript backend in that case. We also have some additional components of CheerpJ which are still written in C++ and compiled using Cheerp. Then there is the file system backend of CheerpJ, which is also used in CheerpX, and so on and so forth. So there is all these sort of components which are used across the various projects and makes it possible for us to kind of sustain this development process of all these very complex things at the same time.
So CheerpJ compiles Java to JavaScript or to WebAssembly?
To JavaScript at this time. The thing is that WebAssembly is not truly a suitable target for Java right now. So pretty much in WebAssembly you will need to deal with garbage collection yourself. While if you generate JavaScript code, the browser takes care of that, right? So it's a significant less thing to worry about. We eventually plan to also support WebAssembly, of course.
I'm sorry, I was just saying there are other WebAssembly targets that use garbage collection. Like, isn't there a C# to WebAssembly compiler now? I believe
so. There is, I think that's Blazor, right?
Yeah.
Microsoft. You can certainly do it. You can always do everything. The question is what is convenient in the end. Okay. We don't believe that WebAssembly is the right target for Java right now.
Okay. I'm just so curious what the performance looks like from Java compiled to JavaScript, because JavaScript engines are so crazy optimized now, and I'm not as convinced that as much effort is being put into optimizing JVMs these days as is being put into JavaScript engines.
Yeah, back in my university time, I spent some time also working on programming language theory, and actually from the academic point of view, the JVM is understood correctly, is recognized as state of the art in virtual machines. So the JVM is actually also crazy optimized. Of course, the problem is significantly simpler because JavaScript is much, much more dynamic compared to Java. But in practice, the level of slowdown we see with CppJ is below 2x compared to run it natively. So it's very fast. Our customers run routinely extremely big swing applications. It's fine. The performance ceiling is great.
So you have to recompile all of whatever Java library is also being used into JavaScript.
So with CppJ, we actually provide a full OpenJDK compiled to JavaScript. It's part of our runtime. So full thing. So it's not just a subset. So there are many projects that try to run Java in various ways in the browser, but most usually they have very strong limitation, like no reflection, no multi-threading, nothing graphical, whatever. In the case of CppJ, stuff just works out of the box. Pretty much the only real limitation is that you cannot run Minecraft because it uses native code. So any 3D application will use native code to access JNI. Yeah, via JNI, and JNI does not fit in this model, but everything which is pure Java will just work.
Okay. Then what's CheerpX then?
Well, it's one step further. So instead of limiting yourself to just one language, the idea is that you can run any x86 binary safely in the browser.
Okay.
So in the first use case that now we are publishing due to timing constraint is the ability of running the actual Flash Player binary from Adobe in the browser, even when plugins are not supported anymore.
Of course.
Okay.
Well, of course
one does. Right. Yes.
But the thing is that it's not only that, right? I'm not sure if you had the chance to see the demo we published a couple of weeks ago, which is our REPL demos. So if you go to repl.leaningtech.com, you will be able to run either Node.js or Python or Ruby, a shell of these three languages, directly client-side in your browser. And this is not like pre-compiled to WebAssembly. This is just the actual packages from a Linux distribution, from a 32-bit Linux distribution, running in the client.
Wow.
Do you want to tell us a little bit more about what's going on there? I mean, what type of performance hit that might have?
Yeah, so when I started thinking about this project, but maybe 5 years ago or something like that, but I started actually working on it. We managed to allocate the time as a company to the project 2 years ago or so. And when I started, my target, like my objective, was that I would be happy if we managed to get a 10x slowdown compared to native. The thing is that we are somewhat better than that right now, and we are not done with the project yet. So the level of performance is actually is great. I mean, I'm sometimes when I work on this every single day. So for me, mostly I tend to be unhappy about the state of performance, and I like to make it better. I profile, I optimize all this, but every now and then I manage to look at it from just a step of distance, and I realize that already what we have achieved is pretty incredible. And the way this works is that it's in the end, it's not even, it's just what you would expect, right? There are multi-stage execution system, multi-stage VM, where you have a fast interpreter and a just-in-time compiler that triggers for sufficiently hot code. And this just-in-time compiler will convert the binary code to new WebAssembly code that can be executed at almost native speed by the browser. So there is lots of moving parts. It's an incredibly complicated problem, but in the end, it's the pieces of the puzzles are always the same. This is how you make VMs.
Okay, so now maybe the next question I'm going to ask, but is CheerpX written in Cheerp with Cheerp?
Yeah, sure.
Okay.
So somehow I guess it's not something usual for a software company, but I think you could say that we are a vertically integrated software company because we control the whole stack. So all the tools we use are made by ourselves, and we actually are also contributing to the WebAssembly standardization project itself. So we are making proposals. We'd like to standardize the branch hinting as part of WebAssembly, which is going to be very useful for Cheerp. So we try to extend all the way along the stack, both at the top and on the bottom.
That's pretty cool. Getting to write, I'm assuming you're using C++ to write Cheerp in. Yeah, right. That's, I imagine that there are a couple of people listening to this who will be applying for internships now because it sounds like a lot of fun, personally.
Oh, that would be great. No, it's fun. It's also very challenging. So pretty much the stuff that we do tend to be things that you will not find the answer to your problem on Stack Overflow. It takes lots of deep understanding of complex systems to do this sort of to work in compilers in general. It's not the easiest of tasks.
Sure.
Right. Yeah. So yeah. Okay.
What are some of the most complex programs you're able to run through Cheerp?
To me, the answer would probably be so that I've not yet found something that doesn't run. So the Flash plugin is an incredibly complex piece of software which has been written over 20, 25 years of time.
At least.
At least. That works fine. Node.js, to clarify, the Node.js that runs in itself includes the V8 just-in-time engine.
Oh, wow. Yeah, okay.
And all this stack of virtual machines work, which is pretty crazy. But actually, the next demo we want to publish is going to be a graphical demo. So we will actually have the full Xorg server running in Cheerp. And if we manage, I have a prototype already. I need to polish it up. I plan to also actually show a Windows application running under Wine on top of Xorg in the browser.
Okay.
That's my next the target for my next demo.
That works. I was going to suggest QEMU running Win3.1 or something like that.
Oh yeah,
Wine works.
Well, that's a good idea actually, running QEMU. I can consider this. Thank you, Jason. It's cool.
Very cool. I feel like we've gone over a lot. Is there anything else you want to tell us about or plug before we let you go today, Alessandro?
No, I just wanted to thank you guys for having me here. I think members of my team have been pestering me to get in touch with you somehow and get an interview at various points over the last several months. So I'm very happy that I can now put them to peace about this.
Awesome. It was a lot of fun. Thanks.
Yeah, it's great having you on. Thanks, Alessandro.
Thanks, guys.